Quantox is a web and mobile development company, basically software development company that has offices in a couple of countries. We represent Germany in this consortium, but we also have offices in Serbia, in Macedonia. We exist for over 15 years, I think, and we are really skilled in tech, let's say. So it's not just single projects. We have a lot of niches. We do mostly web and mobile applications. Well, that's a helpful comparison, but not exactly like Amazon. So Amazon is a B2C for finished goods, and our platform is a B2B wholesale platform specifically for secondary textile materials. And we're connecting sorting facilities with recycling facilities. So like the critical difference is that every listing we offer carries rich and structured data about materials. So for example, exact fiber composition percentages, fiber length, dye types, hazard flags, recycling route compatibility, and a lot of others. So recyclers just don't want to take textile waste, any of them. They need, let's say, for example, polycotton blends above 60% polyester, and our platform enables them to do precise matching like that. Even today, many of our consortium partners already exchange those materials with each others, but they do it either through phone or maybe some custom-made software, but it's not standardized. So what we are aiming to do is to digitalize and automate those existing flows first, and then open our marketplace to third parties. So it's not exactly Amazon for trash, but it's more like a commodity exchange where data attached to the materials is what make those trading possible. We do it through several layers. So first, every textile batch that's come to the recycling facility gets its own unique digital identity. Ideally, it's to RFID tags that are already in the garment, or they can be created at the facility using some sensor data. Then the secondary those materials move through the value chain, and each step is recorded through a standardized EPSIX event through our API. So basically, we have like sorting, shipping, receiving, and transformation of the materials, and this creates a full chain of custody. Third step is our API that's going to expose the structure product data. For example, fiber composition per ISO standards, hazard flags, recycling route compatibility, and certificates. This is what we already built in our open API specification. We have those endpoints ready. And then the fourth step is actual marketplace, which is going to match supply to the demand based on all of those parameters. For example, a Danish sorting facility, they post that they have available bales with all this data attached, and then Dutch chemical recyclers search about their specific technical requirements, and the platform just do the matching. And finally, our partner Zentrix Lab, they are working on the blockchain layer that ensures that data is not altered once published, so that recycler can trust composition has not been tampered with after it has been recorded. So in short, we just sensor generate the data, GS1 standards make it interoperable, our API make it accessible, marketplace make it tradable, and then blockchain makes it trustworthy. Okay, well, because you cannot recycle if you cannot identify what are you actually recycling. So every technology has specific input requirements. For example, mechanical recycling needs long, clean fibers. Chemical needs specific polymers. For example, a garment that's 70% cotton and 30% polyester, it has a different path than just being 100% polyester. And without composition data, material either goes to the wrong process or they just goes to the landfill. So this uncertainty is the number one bottleneck in the textile recycling industry today, not exactly the technology. So that also creates trust. For example, a manufacturer buying recycler yarn needs to verify its origin, composition, compliance. Without that, recycled materials cannot compete with the virgin materials, and the market keeps extracting new racers all the time. That enables optimization over time as well. So when you track every batch end to end, you can learn which feedstock caused some recycling failures or some logistic bottleneck, and which sorting parameters produced highest value output. So you shift from reactive waste management to data-driven circular supply chains. So bottom line is bale of mixed textile waste with no data is worth nearly nothing, and it's headed for the landfill. So that same bale, verified composition, hazard screening, recycling group classification, it becomes a tradable secondary raw material. So that's where data turn waste into resource that we can reuse.